Um, Hope you guys had a good weekend, a good day, good Monday. I know mine's been busy. I don't know about yours. We don't have too much to cover today, but we're going to wrap up OpenSCAD. I'm going to have to delay the printing news until Wednesday. I have to say that was my fault. I wasn't able to make the meeting last night to get the update, so I apologize about that. But as for today, we're going to work on OpenSCAD, and I have a challenge for you guys to build. I think you both have the document, so the PDF that goes through the whole OpenSCAD note. So you can look ahead if you want, but I would suggest that you try to attempt it on your own if you haven't already looked at the final challenge. But we're just going to go over a few of the more nuances with Tinkercad, I guess, or some of the more powerful features. I'll pull up what you just sent me, Gabe, while we wait in case the two arrive. Let's see what you got. Oh, that's very cool. And Jaden, you said you had a great day. I'm glad. Working on your RC project? That sounds really cool. Manage the control surfaces and build a campfire in the backyard and roasted s'mores. Oh man, I'm so jealous. I wish I had a backyard to roast s'mores in. I've only got a porch, which I'm not allowed to put a grill on, but I think I can grill outside if I go downstairs. That sounds really nice. Gabe, this is a really cool iPod case. I like it a lot. Click on your account. Can I just go into your account from here? I'm not sure if I can do that. Oh, here? Hey, Kevin. I hope you had a good weekend and a good day. We're going to wait a couple more minutes, but for now, Gabe sent us his profile to check out his things. If you want to send us anything, I'm happy that we've only looked at Gabe's things so far, but he's the only one that sent stuff, so you are all welcome to send anything, and we'll check out what you've been making. Very cool. I particularly like your unknown thing because of the mystery. Just, what is it? The plant. It reminds me of Mario or something like that, maybe from Mario Kart. Let's see. Yeah, very sim-like with the triangle, like you're controlling the plant. That's your goal. Your skull. Did you modify it? I remember seeing this. Oh, is that? Oh, it's hard to tell. Let's see. Well, I can tell this one's going to take a while to load, so I'm not even going to try, but it looks like I can't rotate it. Okay, so we'll go ahead and get started. Kayla will probably join us pretty soon, hopefully. Let's see, Kevin, I just mentioned to Gabe and Jaden that I have to apologize. I missed the meeting last night to catch up with updates, so I can't give you, I don't have any link to send you for the 3D printing, but since I didn't get an email, I can only assume that it's not actually ready yet. I hope I can tell you it's ready on Wednesday, but I haven't heard any news. So let's see. Yeah, we'll just have to wait on that. Today we're going to wrap up OpenSCAD. I'm going to turn over a challenge to you guys. Did you all get OpenSCAD running? I think you all had it last time. I just wanted to check. You don't all have to answer if you don't want to. My real question is, does anyone not have it installed? And if you do, go ahead and pull it up. All right, so I'm switching over to the challenge slide, but actually the real purpose in going back to this slide was it's really how we approach our challenge in OpenSCAD is, what shape do we need, how big do we need it to be, and where should it be centered, and located, which axis, that sort of thing. So those are our primary questions we want to ask. Let's see. Yeah, here we go. So here was a solution. We already went over this to get the other ball of the dumbbell. An alternate solution, I think we went over that as well. So let's pick up here. With color, we mentioned, I think, before that this doesn't actually translate into color, like real colors in 3D printing, unless a particular type of printer can understand colors, but I don't even think the standard format RTL, let's check right now. Before I speak too quickly, let's check what Wikipedia says on RTL. Did I get that right? Let's see, 3D file. STL, RTL, okay. Wikipedia, STL, file format, there we go. Okay, so let's see if it does anything color. Oh, yep, okay, only describe surface geometry of a three-dimensional object without any representation of color, texture, or other common CAD model attributes. So, yeah, basically, there's no color in the standard STL file. I don't know what Tinkercad uses. I guess we could check their documentation. I won't get into that now, but it looks like there's some non-standard variations on STL that give you the add color. So it's possible if the 3D printers can print in color and read that type of file, that might actually translate. But we'd also have to check in OpenSCAD if they, when they print as an RTL, whether they follow the strict guidelines on RTL. I mean STL. STL. I keep saying RTL. That's STL. If they follow, if they export there, you can export as an STL in color as well or not. But that would take a little bit of digging. But since we can't print in color anyways, we won't go into it. But it's nice to know it's there. It's really handy in OpenSCAD for troubleshooting, seeing and visualizing your pieces, or if you're not going to print it, but you're just making some cool shapes, you can definitely add some nice designs. Gabe, just send me your question. Okay, so the model is grouped in Tinkercad and you can't resize it. with specific height and length. Add a ruler to the plane, then click on that model, that grouped model, and then you should be able to resize it with your own specifications. Jaden just made a really long dumbbell. Cool, I'm glad you're experimenting with it. So here's a bunch of different colors. I'm not sure if you've ever seen RGB format before, but that's worth mentioning. So there's some standard colors. You can type in color green, color red, color blue, your normal colors. But we also have a wide range of colors that, a lot more fine control that your computer can display, and you can tell it very specifically what colors you want. You specify the amount of red, green, and blue you want, and those are colors, the primary colors of light, and then that last value here is 0.5. That's the opacity, so that's how clear it is. Something that is fully opaque, you can't see through, so if you make the opacity 1, which is the default, if you were to just choose green, it'd assume you meant you can't see through it. And so if you make the opacity 1, you can't see through it. If you make it 0.5, then you can, that has half opacity, so you can half see through it, I guess. Just you can experiment it around. If you make it 0, it's going to be invisible. That's probably not what you will have intended, and that might even confuse you, because OpenSCAD will think if you make it something with opacity of 0, it'll look like a hole, but in fact it'll actually be a solid shape, which is probably not what you would want. So just be wary of that. But actually making the opacity, reducing the opacity so that you can see through some object that's toward the front to see what's behind it can help you troubleshoot as well. So those can be some really good tools for that. All right, so that's color. Here's some RGB values for different colors. Fuchsia is a mix of 100%. So yeah, it goes from 0 to 225. 225 is the highest you can go. So is like full, RGB, red, green, blue. So fuchsia is 225 red, is no green, 225 blue, and what do you get when you combine blue and red? You get, what they call fuchsia. I guess I would normally say violet or purple, but looks like purple's darker. Black is all zeros. White is all 3 colors of light combined. Black is technically, as far as light is concerned, black is the absence of light. White is the presence of all light. So that's how our eyes perceive the color. So that's how we use it here. So you can refer back to this. Yeah, Jaden just made a red dumbbell. So yeah, you can make all kinds of things. Oh yeah, and I'm not sure if I mentioned that this opacity value is often called alpha. So you'll see it have an A at the end, RGBA in the documentation. Alpha is just the Greek letter that's commonly used to denote opacity. So now we've only been creating one object at a time, but what if we wanted more than just one? For example, what if we wanted 5? Well, we can copy paste, and end up with, well, they didn't show us the code, they just showed us the answer. You can copy and paste and spread them out. Let's show what this might look like. Okay, so A equals paste 5 times, and we want to just put them all in a row, so we'll do 2 times A there, 3 times A there, 4 times A there, 5 times A there. Now, let's see what happens when we run to compile and render. All right. Ooh, we're way zoomed out. I wonder. Let's see. Okay, zooming in. Oh yeah. Did I put the? Yeah, I guess it was our axis. It was okay. So there's our circles. They're fairly small, and they're definitely regularly spaced out because we used one dimension 4 and just multiplied along the axis. What if we want to make another row of circles? Well, yeah, you're right, they're not round. If we zoom in, they look like hexagons. So what did we figure out last time about this? Didn't we say something about, does anyone remember the command that we used to increase the resolution? I'll give you a hint. Oops, I copied and pasted something else. Let's see, one sec. You can find it here. So someone tell me what I need to type right here after R equals B. I'm going to put a comma. What do I need to type to make, we wrote circle, and we know, we've seen it make circles before. Let's try it. Res equals 10, so that's J. F6, okay, I'm going to start hitting F6 instead. F6. It looks like it might have ignored that, just in case. Nope, it doesn't do anything with res. Anyone else have an idea? Maybe it's not on the cheat sheet. Did I tell you it was on there, but it's actually not? Oh, I should have checked the cheat sheet. I just assumed it would have been there. Let's see. Oh, I don't see it. All right. Well, we can go back to notes and scroll up. Is this working? No. Okay, here we go. Highlight, transparent, intersect, difference, duration, union, Boolean, resolution. There we go. Okay. Cache FN. Not the most memorable thing, but there we have it. Let's go back. Okay, so go back to OpenSCAD. Cache FN. Okay, so this is another good example. So we came in, okay, well that FN equals 10, that's pretty good. That was quick, it didn't take any time for it to render 10, and it looks much better. So what I'm going to do is I'm going to copy and paste again, Control C, right here, Control V, Control V, Control V, Control V. All right, let's check. Make sure they all look good. Yep. Okay, there they are. All 5 of them. All right. So, what if I decide, actually, never mind. I think I want them on the other side of the y-axis. So instead of negative, I'm going to get rid of all these negatives on A. 1, 2, 3, 4, 5. See if that worked. Compile and render. Oh, there we go. Okay. So now they're on the other side. Actually, you know what? Never mind. Let me switch them back. All right, hit Control-Z a bunch of times, compile and render. Okay, good. There we go. Now, what am I getting at here? Do you want to make this change 5 times to every circle each time? Probably not. 5 is kind of manageable, but let's say we're just testing things out and eventually we're going to end up with 100. And we're going to copy and paste 100 different in 100 different little circles every time we want to shift them all. Bad idea. Gabe says he would, but he has too much time on his hands, I say, or he's not lazy enough. he said he's kidding. Okay, so now what do we do? Well, there's a solution for that programmatically, and it's called a loop. Yes, I did mean not enough time on this. So yeah, a for loop in particular is a certain type of loop. You'll see others in other programming languages. OpenSCAD might have more loops. I've only learned about the for loop so far, and that's all I've ever needed to use. But a for loop is used to, it executes an exact number of times. In fact, it executes n times the same bit of code. So we talk about these as running through iterations, and each iteration n, or usually not n is the maximum, the highest. Usually it's I or index or some other more meaningful variable name. Will take on the next value in a sequence. So what do we mean by this? Well, this is how it looks. Up here in yellow, you can see this is how they define it in the documentation. For open parentheses, close parentheses, we put a condition in here. No, sorry, not condition. We put a state. We set up, give our values that we want. So for I, which is a new variable, typically you use I just because that's kind of convention. It can be whatever you want. It could be your name. Most people try to stick with something, either the conventional I or something more meaningful if you're looping through, say you're looping through, you want to put in a bunch of letters in a certain sequence, what's that famous sequence that's, I'm drawing a blank on this guy's name. Okay, I'm going to search this because I want to use this as an example. 1, 1, 2, 3, 5, 8. Fibonacci. Okay. So say you wanted to go through the Fibonacci sequence. You could go in here. Well, okay, I'll keep explaining this. I'll use Fibonacci as an example in a sec. So for I, which is our counter, equals open close brackets. Here's your list of numbers. One option is to do start colon end, and it'll increment by 1 from start until it gets to the end. You might put for I equals 1 colon 10, and it'll loop through this for loop 10 times. And what does it execute? Well, whatever you put in between these curly brackets here. So in this case, I equals 1 colon 5. So each time you iterate through, I will be set to first 1, and then 2, 3, 4, 5. So count those up, 1, 2, 3, 4, 5, and you get 5 times. And it's important that I becomes equal to the number of the iteration that you're going through, because we'll use that. Also, you can add a step. So say you want to make this, loop through the degrees of a circle in increments of 30. Well, there's 360 degrees in a circle, so if you want to start at 0 and end at 360, then and you want to go increment angle like 30 degrees at a time until you get back to where you started, then you would start, so your first I would be 0, your next I would be 30, your next I would be 60 to 90, and so on until I equals 360. So basically, in this example, if you leave out the increment, that's that middle number there, then it assumes that the increment is 1. So 1, I think this is I think this probably makes sense. Okay. Yeah, the increment, step, that's the same thing. I'm using different terminology, I guess. But I should stick with theirs. Start, step, end. So this is how much do you want to step up each time? So here's an example. I'm going to ignore this example and use the Fibonacci sequence. Oh no, I'll do the Fibonacci sequence in a sec, because that one's weird. So we have our old way of doing things, and this is negative a. So I want to make this. I want to make this on the other side of the axis so we can see how easy this is. This takes up, well, if you ignore that the lines are wrapped, 5 lines of code. So, and a lot of copy and pasting. Instead, I'm going to write is 4, open parentheses, I equals, open brackets, 1:5, close brackets, close parentheses, open curly brackets. I know it's a lot of brackets. And in this for loop, traditionally you tab over in a for loop. That's for readability. Different people have different ways of where they put the brackets, but it doesn't matter. Just try to stay consistent so that anyone reading your code isn't going to be confused. They can at least get used to your style. If you program for a living, your company might actually tell you what they like. What was the color code again? Jaden's asking. I believe it's. Let's see. Are you asking for color? Just the command color. You might type color open in quotes red, close quotes, like that, and then square. Okay, we'll just make this. We'll make some red circles, and our green circles or teal circles will be on this side. Okay, color red. Let's see. We want to do circle R equals B. Cache FN equals 10. Okay. Oh, and we probably want to translate it. Translate. Now what do we do here? Let's do A. I don't want to do minus A. I want to put it on the other side, 0. Okay. Let's see how this goes. Design, compile, and render. Go. Oh, probably missed a parentheses somewhere. Maybe. Anyone see my mistake? And Jaden, I don't know what Blender opens. I would Google it. Semicolon. Oh, good one. Okay. Alright. Compile and render. Still an error. What did it say? Syntax error in line 6. Okay. Let's go back. Anyone see my other error? For I equals 1:5. Is that what I did? Open sim. I know, okay. Nope, I don't know. Huh. Well, let's figure this out. So, we'll go back and forth to the slide. sides to see what they did. For open close parentheses, I equals 1:5, and 1:5 is in brackets. Pretty sure that's what I did. Oh, so for loops don't need semicolons, but the statements inside them do, because this for loop isn't actually it's like its own entity, and it's kind of like a function. For loop operates by in its own way, and for loops just have to enclose complete statements. Every statement in there has to be its own new statement, and I didn't put the semicolon inside the for loop. So there we go, compile and render, and we just have one circle over here. What did we do? Well, we definitely did the translate A0. Okay, so what is this doing here? Every time, first I is set to 1, then it runs this code. Then I is set to 2, it runs this code again. And I is set to 3, 4, 5. So in fact, what we did, or what our problem is we're not using I. So since we're not using I inside the for loop, it's just running the exact same code. So we actually printed 5 circles right on top of each other. So let's change this to I times A. Design, compile, and render, and there we have it. We have our five circles. So that was a lot easier. I'm going to make this. Tell me if you can't read this anymore, but I'm going to try to make this easier to see everything at once. Okay, so you still didn't make it red. I use color wrong? Nope. Jaden, were you having this trouble too? Let's try something else. Blue. Well, I don't know. We can get back to the color problem. We'll just remove it for now. Make our code simpler. So here is our design, render. Okay, good. And here's our code. So because they're flat, okay. So copy paste. Now let's say I changed my mind and I actually want them to go up like steps. Well, this is easy. I multiply in the y direction too. Compile and render. Boom, there they go, up like steps. It's pretty easy. Okay, I'll try spheres. I want to make them all spheres. Compile and render. Boom, they're all spheres now. So I'm not exactly sure why my circles disappeared. Maybe my scale is off. Well, that's very strange, but anyways, so the point is, if I want to change all of these into spheres, it's really easy. If I want to change all of these into spheres, copy, highlight, paste, copy, paste, copy, paste, copy, paste. So for loops are somewhat tricky, can be tricky, but good to know. There we go. Maybe it doesn't like 3D objects and flat objects at the same time or something. I don't know. Anyways, yeah, so that's how it goes. Let's test out color equals red again. In fact, I think this resolution is slowing us down, so let's make the resolution 5 and turn it into a variable. Again, it's really easy to change this one, but if I want to change all of these, I think I'm probably made my point. But it's an important one because for loops are worth it. Yeah, that was a lot faster, even though they look like terrible spheres. Okay, so I'm going to get rid of these because they're bad. Duplication of code is bad. It takes a long time to read, a lot longer time to troubleshoot. So when you can repeat, repeat. When you can simplify, simplify. Okay, so let's go back. Oh, yeah, I said I was going to do, so this is one way of doing things. Say I want to have a different number of steps. Let's say I want to step by 0.5. Well, I'll make this a little clearer. I'll make it 0.5. Okay, I can do this. Compile and render. There we go. Now we have 10. So, well, that was easy. Easy enough to switch around. What else? Oh yeah, so now we're not stuck with just using a fixed number of steps apart. We could also do, if we wanted to, the Fibonacci sequence. Type that in there and compile and render. There we go. We have, for whatever reason, we have spheres that are spaced out by the Fibonacci sequence. So the point is, you can use whatever intervals you want. Let's try a test here. Let's see if we can go 13 to 18. Can we just add in this type of syntax? No. Okay. So you can either use a list, or you can use that quick format of 1:5 to have it create a list for you. But you can't mix the two. So what if you want to mix the two? Let's say I've never done this before. I'm just going to go for it. 5 plus 8, 10, 15. If this doesn't work, I'll stop now, but looks like it doesn't like it. Okay. Anyways, that was unnecessary. Okay, let's go back to the slideshow. So, we've seen how we can repeat things. We don't have to put just one line in there. That's a good point. We can, in fact, let's go ahead and go back. What if we do want all of those in there, but we don't, all of those shapes in there, sorry, but we don't want to write all that code we did before? Then we say color blue, translate -I times, no, we said, yeah, I times A, -A, 0. We're still repeating code here, so this is generally not bad. I mean, not the best way of going about things, but we might see how to get past that at the end of today, hopefully. Okay, so we added another comment here, or another line, including the semicolon, which wraps around. Compile and render, and there we have it. So multiple lines. we can negative I times this design, compile and render. We can do whatever we want. So loops don't care what code you put in there. They just repeat, or they'll repeat anything. So they're pretty powerful. You can even, now remember with the difference operator, I won't go through this example. You can try to type it on your own if you like. But remember with the difference operator, we discovered last, in the previous time. Can you see the 5 circles code again? The 5 circles code is this first line up here, Jaden. You could ignore the scale and just do translate square. Oh no, sorry. It's this line. It's this line in here in the for loop. For I equals 1:5. Translate right here. The mirror will just give you is another way of writing the other circles here. So the difference operator, remember we discovered that only puts a positive shape for the first shape that you give it. And any shape afterwards, it subtracts out of that original shape, the first shape. So if we want to cut a bunch of holes, or, in theory these could be screw holes, where you would tighten a screw into, or for whatever reason, you make your first square, and then you put a bunch of circles in them. This is all in flat, but we could do this in 3 dimensions as well. But basically, yeah. Well, you go ahead and try this out on your own. Just get some practice writing a for loop, and then see what happens when you change things up. Oh, sorry, I missed your question. In Inkscape, how do you take the box and put it around the image? Yeah, so in Inkscape, you'll want to go, what was that called? Well, I'll go ahead and pull it up. Oops. You want to go to File, is it Document Properties? Yes, File, Document Properties. You can hit Control-Shift-D also. And then you'll see a plus icon that next to Resize Page to Content. Click that plus, and then click the button Resize Page to Drawing or Selection. If you make that selection, if you click on your particular thing you want to resize the page to, it'll resize to that, or it'll resize to the whole thing. So how are you guys doing with this? Can I move on? Yep. Okay, good. So I already mentioned, I told you how you could do this. So this is your one last challenge before I leave you with a challenge for the rest of today. Much bigger challenge. I think you'll be pretty excited with what we're doing, Jaden. We're going to do something with aircraft and or rocketry. I can't remember which, but I'll be able to tell you on Wednesday. What's up, Gabe? For Inkscape? Yeah, sure. It's Inkscape, actually, by the way, but yeah, no problem. I'll get back to your question in just a sec, Gabe. So, yeah, go ahead and try this loop. Remember, how many degrees are there in a circle? 180 is halfway there. 360, there you go. All right, so with that, yeah, I'll let you figure it out. Gabe, it was under, if you hit File, Document Properties, there's a plus icon that says Resize Page to Content or something like that. And then you want to click the button, after you click the plus icon, you click the button Resize Page to fit the content or select, or the design or selection. Good. Is S4 a phone? Okay, cool. Oh, that's right, Samsung, of course. That's another question I'll have to ask Mr. Dubik. He didn't tell me, so I don't know. It might be it'll probably depend on how many people want to print, and you know how long it takes for the printer to print, which I don't know anything about. So I'll get back to you about that. The complexity is actually not really a problem with the 3D printer because the complexity doesn't actually have any bearing on how long it takes to print. Well, I should say it doesn't have much bearing on how long it takes to print. It's actually the amount of solid material that it actually has to print, because that determines how many times it has to run its printer head back and forth, and you know the number of layers it has to print. The complexity, you know, it can pretty easily not print material wherever it doesn't need to. It just, that's the time saved actually, like the more holes there are, which is really interesting. You'd think something really complicated would be particularly difficult to print, but it just prints one layer at a time. That's how these things work. So did anyone get this, their loop to work? a halo of spheres. It doesn't have to be aligned on the same axis. But if you have, go ahead and paste your code and I'll check it out myself. Still working? So Gabe, he's saying he thinks OpenSCAD doesn't look that great, especially compared to something like Tinkercad. So the difference that you're probably seeing is just how simple it is, how simple it is to make your objects. OpenSCAD gives you a lot more precision, but you have to take the time to build that in. So it takes more work. Whereas Tinkercad, you just drag it around, and it doesn't matter if it's perfect. Jaden, I'm gonna leave you with one final challenge. So we'll go over how you do this. So we count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I guess here they're doing 12. Count the number of spheres. Size is the radius of the spheres. How many times do we want to loop? We have a variable. So anyways, we're going through angles. So we want for I equals 0 to count -1. That's how many total we want to make. 0 is just an easier number to start off with because the first one will start exactly where you want it to. You could go from 1 to count, but it's the same number. It's pretty arbitrary. So you're creating spheres, rotating a certain number of degrees, so you need to pull up the rotate function, give it the number of degrees you want, specify the angle, and then the axis. So we want to rotate along, what do we do in this picture? Rotating along, that's let's see, probably either X or Y, I guess, depending on the orientation of the picture. So let's see, we have 2 spheres, we want them spaced 180 apart. We have 6 spheres, we want them spaced 60 degrees apart. I think we had 10, so if you did it exactly like the picture, then you'd do 36 degrees apart. We do 12, which is what they're doing, I think. Oh, they just take 360 divided by count. That's easy. If you change count, it'll automatically space them out for you. So we do rotate I times count, or I times 360 divided by count. We want to rotate along the x-axis. That one is true for x, like yes, rotate around the x-axis. That's the hard part. Then you just create the sphere. Translate size times 10, r equals size, and we've already added the rotation in. So the rotation is actually where, what's determining where it goes in space. So we don't have to use I any more times. And that's it. I did send you these slides, so if you want to refer back to them, just pull up that email that I sent you. It was probably about a week ago. but it's the most recent email that I sent out to all of you. And so now that we've done practice looping, and we used, if you did use a variable, you can switch count to 3 and it'll evenly space 3 spheres around the x-axis, or you can make it 18. And variables give you the power to change these things very easily. So you can also use it to make holes. One sec, Jaden, I will. Yeah, okay, so where's the code? Here's, did I miss it again? Yeah, sorry, skipping around everywhere. Okay, here's the code. I guess, yeah, we'll just end here for the day, and I'll give you a challenge tomorrow, or on Wednesday, for the much more complicated OpenSCAD design that'll incorporate a lot of different things that we've learned. But there is one more challenge after this. I made a mistake. Another looping challenge before we get to the big one we'll get to tomorrow. So I'll leave you with the next challenge, which I'll go ahead and say is to create an American flag. So you just need to do two-dimensional object, but the important part is the tricky part is figuring out how to nest. I'll go ahead and give away the key, nesting for loops. All right, Peyton says you got it. So okay, so here's the code to create one single star. I'll give that to you, and my hint is you have to nest for loops to make the flag. So yep, this is one star. I'll go ahead and, can I copy this? Nope. Well, I'll let you go ahead and copy this down. I'll leave this here for the rest of the time. So once you have this one star, I want you to give me 50 stars, 10 by 5, and then 13 stripes or rectangles with the stars sitting on top of them. If you want to do another flag, by all means go for it. But the American flag, at least do the American flag first, because, well, at least do this flag, whether you do it first or not doesn't matter. Yeah, because I want you to figure out for yourself how to nest the for loops. I'll give you one more hint that nesting for loops involves using more than one counter variable. So you can't use I and then I again. Convention says do I and J. It might help you to think, if you wanted to build rows then columns, you could do R and C, or row and column, something like that. You could set it as a variable. I'm just throwing out possibilities, but I'll let you figure out. It doesn't matter how you do it. The only way you can't do it is you can't repeat your code. You get only one line to make a polygon star, and you have to put that inside of 2 for loops or nested for loop. If you don't have time, that's okay, Gabe. But it's a challenge for those of you that have the time. Yeah, I'm sure your homework takes priority over this class. This class doesn't get you into college or anything. So yeah, this is, you're taking this class because you want to learn more about engineering and some tools, and so you know rather, yeah, it's entirely up to you is what I'm saying. Okay, so it's 7 o'clock. I look forward to seeing you all on Wednesday. Have a good night.